am back. All right, number 19. In number 19, it says you're given three graphs. One of the function, the derivative, and the second derivative. Determine which one is which. So these are polynomials to look at. So let's look at them together. And we're just going to sketch the answer in our notes, okay? So for number 19, what am I looking for to know which one must be the derivative, the first derivative, or the second derivative? So one thing we need to recognize is that whenever we take the derivative, the degree gets smaller, meaning the greatest exponent. So when I look at the shape of these polynomials, which one has the greatest degree by looking at the curve? Well, if I'm looking at this, I see a line that has a degree of 1. I have a parabola that has a degree of 2. And then a cube function or something like that would have a degree of 3. So which one's the greatest one? That's the function. So the function, obviously, is going to look like that. How about the first derivative? What is it going to look like? Well, if you take the derivative of this, it goes down 1 degree. So what would the function then look like? The parabola. And then what would the second function look like? Well, if you take the derivative of a parabola, it's now going to be a line. So you're looking for the one with the greatest degree, and then when you take the derivative, it goes down 1 degree, and then it goes down another degree, and we're just sketching the ones off the graph to make sense of it. 20, let's do the same thing here. Which one has the greatest degree of the three pictures that you see? So I see a horizontal line, a parabola, and a slanted line. So the one with the greatest degree is the function. So that's this one, the parabola. Then the derivative is, what's the derivative of that? It has a degree of 1. Now, they're both lines that are left, but the slanted line has a degree of 1. When you take the derivative of a slanted line, it now becomes a constant, no variable. And the graph of a constant is horizontal. So the second derivative is horizontal. 21. It says, if f of x equals 5x squared, subtract 3x plus 2, the derivative at 1, it says, use the alternate form to find that using limits. Now, I normally wouldn't use limits for this, but we're practicing so we don't forget this. So if we're actually finding it at an x value, it says x approaches 1. This is what we're going to do. Then it's f of x, which is 5x squared, subtract 3x plus 2, subtract, and now I actually plug 1 in and get a number. So when I plug 1 in, it's 5 take away 3, 2 plus 2, so that's 4. And that's all over x subtract 1. So that's what I'm looking at. So I'm going to simplify this. So the limit as x approaches 1. We have x subtract 1. So this is 5x squared subtract 3x subtract 2. I need to factor and then simplify. So right now, it's indeterminate. So if I plug in 1, it's going to be 0 over 0. So I need a factor. Now, I already have a sense of this, so I'm going to use it. That x subtract 1 is going to divide out for this to work. So I'm going to use that fact to help me factor the numerator. So x times what is 5x squared? That's 5x. Negative 1 times what is negative 2? That's plus 2. So now, make sure that works. That's negative 5 plus 2. That's minus 3. It totally works. They divide out. Now plug in 1, and you get your answer. So the derivative at 1 for that, the answer is 7. All right, 22. In number 22, the position function of an object is s of t equals 2/3 t cubed, subtract 5 halves t squared plus 3. That's position. And it says find the displacement between 0 and 3. Well, displacement of an object simply means where did it end. So in this case, the end time is 3. So you plug 3 in, and you subtract, and you plug in the beginning time. In this case, that's 0. So all you do is plug in where did it end and where did it start, subtract it, and that is called displacement. So when you plug in 3 and you plug in 0, so when you plug in 3, you get negative 1.5. When you plug in 0, you get 3. So when you subtract that, the displacement of the object is negative 4.5. So what does that mean? So that means that it ended up 4.5 to the left, at least in terms of where it started. Okay, so from where it started to where it ended, that's where we're at. So this object, if you like, started at 3 and ended at negative 1.5. So from where it started to where it ended, what's the displacement? So that's where you get negative 4.5. Now the second question is different. Second question is total distance. So for total distance, I now have to take the velocity to know what direction it was going between 0 and 3. So what is the derivative of this? 3 times this, the 3's divide out, you get 2t squared. 2 times this, the 2's divide out, you get minus 5, subtract 1 to the exponent, and the derivative of 3 is 0. I want to make it equal to 0. I want to solve it to know when the particle is at rest. So I'm going to factor out a t, so that's 2t subtract 5. So one answer is 0, so the particle is at rest at 0. But I want to know if the particle is at rest somewhere between 0 and 3 for time. So the second one is you would add 5 and divide by 2. So 5 over 2 is the same as 2.5. And the reason I'm writing it as 2.5 is so that you can see 2.5 is between 0 and 3. So between 0 and 3 was the particle at rest. Yes. So I actually don't need to know the direction of it. I just need to be aware that at 2.5, there's a rest. I know if I plugged in positive 1, it's negative. If I plugged in 2.75, it would end up being from a negative to a positive. So it changes direction at 2.5. So then how do I find the total distance? Well, I'm going to use 2.5. So then the total distance is plug in 2.5, subtract, plug in 0, and we want the absolute value of that, because it's going to be a positive answer. Then we're going to plug in 3, subtract, plug in 2.5, and again the absolute value of that. So if you think of our number line in terms of time, so if you think of time from 0 to 3 seconds, then at 2.5 seconds, we are going to the left and then going to the right. So what I'm doing is, I'm finding the distance from 0 to 2.5, that's what this is. This would actually be a negative answer, but I'm doing the absolute value of it. And then I'm doing from 3, or 2.5 to 3. This one actually I don't need the absolute value because I know it's going to the right, so it'll be a positive answer anyways. And then I'm going to add these two up to find the total distance. So what distance did it go to the left, what distance to the right, and then add them up. So if I did that for 22, and if you used your calculator, you would see what? That at 5 over 2.5, it's negative. So it's negative 2.208, subtract 3, plus, at 3, when you plug it in, you get negative 1.5, subtract negative 2.08, that's where that positive answer is going to come in. So when you plug 2.5 in, you get this into the position equation. When you plug 0 in, you get that answer. when you plug 3 into the position and when you plug 2.5 into the position. That's what you put in your calculator, and then in the other side of your calculator, your answer would be, and you only have to round to, you don't have to round, it's 5.916. And there's no meters or anything given, right? No, it's just that. So, do you know the difference? Obviously, is there more work in displacement or total distance? And the answer is, of course, total distance. 23. Last one. Hooray. So, the height in feet of a ball. So, this is a real situation. So, time is going to be 0 or greater. And you're given an equation of that ball. So, the height is negative 16 t squared subtract 22t plus 220. So that's the position of the ball. So if I plug in 0, it starts at 220. That's why it's being thrown from a tall building. So what's the ball's initial height? So if I plug in 0, the initial height is 220 feet. Next it says, what's the initial velocity? So to find the velocity, first of all, I got to solve for the velocity. So to do that, take the derivative. That's 2 times negative 16. Subtract 1 to the exponent. Negative 22t, that's negative 22. And the derivative 220, 0. Then if I want to know the initial velocity, plug in 0. And you're left with, and we need to have units. So it's feet per second. So what does that mean? So velocity gives you direction, not only speed. So it's going at 22 feet per second, but that negative in front tells me direction. And off a tall building, that means the ball goes directly down to begin with. So negative 22 doesn't mean it's going backwards. In this case, it means it's going down instead of up. C. What is the speed of the ball after 3 seconds? So here's a situation where speed is the absolute value, right, of velocity. So whatever the answer is here, I need to do the absolute value of that. So that is negative 32 times 3, take away 22. Yes. Let's see. All right. Here you go. All right. Be nice to me. So negative 96 take away 22. What's the absolute value of that? So the answer is negative 118. But because it is speed, we always write that as a positive answer. And unit is feet per second. All right, last one, part D. Then we're done our assignment. How far does the ball travel in the first 3 seconds? So to figure out how far the ball travels in the first 3 seconds, notice it's being dropped from a tall building. So it's only going in one direction. So because of that, all I have to do is figure out, first of all, what's the position at 0 and at 3. So we already know at 0, but I don't know at 3. So the initial is 220 meters. At 3 seconds, I got to plug 3, and you can use your calculator. Plug 3 in. And the height of that at 3 seconds is 10 meters. So the question is, how far does the ball travel in 3 seconds? And the answer is 220. Again, 220, take away 10. So the answer is the ball travels 210, did I say meters? Is it feet? It is feet. So feet. So the ball travels 210 feet in the first 3 seconds. Perfect. Mr. G Math, over and out. I'm proud of you that you're doing your work, and until next time.